Welcome everybody. Today we are going to get into working with Cura, which is the slicing program we installed in class last time. And we're going to talk a little bit about the options that Cura offers to configure our objects to be 3D printed. And if you remember, we talked a little bit last time about how 3D printers work, and that is that they are laying down individual layers of melted plastic. And a 3D printed object is built sort of from the base up, layer by layer. And that imposes some restrictions on what sorts of things you can print. And it also means that you have to prepare the object before you send it to the 3D printer by doing something called slicing. Because the 3D printer doesn't know how to print an object. It just knows how to execute individual lines of what's called G-code. So you've got a program in between your either design or the object that you download online and the 3D printer that prepares it and figures out how to generate the 3D printer commands that then the 3D printer will run. So the first thing I'm going to do is open Cura. It's called Ultimaker Cura, which you've probably already noticed, so it's down with the U's. And it takes just a second to load up. And then when it loads up, we're going to see the build plate, empty build plate that we saw the last time. The printer you should have is a Creality Ender 3 Pro. That's the one we're working with in class. That's the one we configured last time. And you'll notice I've got another printer up here. You can have as many printers in Ultimaker Cura as you want. I have worked with two recently, so those are the two on here. So a couple of notes on how to navigate in this view. The scroll wheel on the mouse zooms in and out, and you can use two fingers on your scroll pad to do that. On a physical mouse with a middle button, you can pan. So I'm holding down the middle button to pan. That is not something that I have figured out how to do on the trackpad, but it's also not a particularly important movement. If you hold down the right mouse button, you can rotate. That's really the most important one when you're plating things. This is called plating, when you put an object on here and sort of arrange it before you slice it. And you can do that on a trackpad by clicking with two fingers and moving it around. So try those out. Make sure that you're familiar sort of moving this around. And we're going to load up an object on here, and I will give you all this same cube to load. Let's see, I think I've got it in my documents folder. Yeah, and you'll notice the file extension here is an STL. That's one of the standard. Spotlight or Finder or whatever knows what it looks like, and it knows that it's a cube. So I can open it here, and a little cube shows up on my 3D printer plate. So I can zoom in, I can rotate the cube. You'll notice that I've got some controls over here now, so I can move it around if I want it to print at a different place on the plate. And this is a representation of physically where it will be printed when I start running the 3D printer. It doesn't really matter. It's a pretty small object. It's much smaller than our build area. Sometimes if you're printing something really big, you'll have to move it around, and you may even have to rotate it to get it to fit on the build area. And if you hit the rotation thing over here, you'll notice you've got X, Y, and Z axes. So I can rotate it like this, which doesn't affect how it's printed, except that it'll come out. The layer lines will be oriented differently, but if I rotate it like this, that is going to substantially affect how it's printed. And in fact, we'll talk about this a little bit later. We'll look at some failed prints, but if I printed it like this, it would probably fail. I don't think that would be a very good print. So we don't want to do that. And we can just rotate it back, and it'll automatically drop it down to the build plate. Some of these tools I'm not familiar with. This one says that it mirrors it. Maybe it flips. This is a perfectly symmetrical shape, so maybe it's flipping some stuff around. One of the other ones that I will frequently use is scaling. And sometimes you'll print something and it's a little too big or it's a little too small in a uniform way. So you can do scaling. So if we want to make the cube bigger, this is a 20 by 20 millimeter cube. We've made it 150% of its original size, which means that it's now a 30 by 30 millimeter cube, and I can see this down here. So if I want to get it back to its original size, I can go to up here and put in 100, and it'll go back to its original size. I can also add additional cubes in here. I think you can multiply it. So if I want to make a bunch of cubes all at once, I can multiply it, and you'll notice it'll space them out a little bit, and it puts them close together because that's the fastest way to print it. I can also add a cube from a file. Sometimes you want to print multiple files at once. Now, the only thing we've got here is a cube. You can drag to change the size. That's not particularly useful for a cube, but maybe sometimes you'd want to do that. We're going to set this back to 100%, which will set it back to 20 by 20 millimeters. So there's a lot of different tools. This process is called plating, arranging things on the build plate for slicing and then for printing. And Cura, a lot of slicers are very similar in the suite of different operations they offer. We're just using Cura because it's the one that I'm most familiar with. So I'm going to delete all these cubes. And to do this, I'm just clicking on them and hitting the delete key on my keyboard. And so we're back to our singular cube. So I want to go back to move. I want to get it centered approximately on the build plate. It doesn't have to be perfect. But let's say I want to actually print this cube. So you'll see there's a slice button down here. And if I hit this, it'll slice the cube with the settings that I've got configured up here. And we haven't talked about these at all. But one thing I want to show you is you can go to a preview view and you can see layer by layer and sort of step by step how this is going to print. So a couple of things. There's 71 layers over here on the right, and that is 0.28 times 71 is probably 20 millimeters. This shows you what the layer height is. And the layer height is important in determining the visual quality of the object. Thicker layers look lower quality, thinner layers look higher quality. And you can see I can scrub this down and it will show me at layer 13 how much of it will be printed. We talked about this a little bit last time, but it's not solid all the way through. That would be a waste of plastic. A lot of times you don't need the marginal additional strength that comes from printing something out of totally solid plastic. So it's got this thing it does called infill that is inside of solid surfaces inside of solids of a sufficient size. It will create what's called infill. It does this automatically, and you can see that this infill is moving every layer. And then when it gets to the top, it will do a couple of layers. So it's 68, 69, 70, 71. It's doing 4 fully solid layers. And then you can sort of see on the side here, it's got the red and the green. And so it is doing 2 walls. Those are called walls on the outside. And then it's doing infill inside of the walls. So the walls, the base layers, the top layers, and the walls are important settings. The defaults are usually okay. But they'll determine sort of how stiff your object is if you take it and squeeze it. And if you're making parts that fit into other assemblies or that need to hold weight or that need to resist forces, then you need to pay a little bit more attention to infill. For a cube, and these 20 by 20 millimeter cubes are commonly called calibration cubes. You use them to sort of figure out if your printer is working correctly, which is what we're going to do. It's not super important what the infill settings are. The other thing I'll say is you notice there's a little circle around it. That's not really a circle. That's like a rounded square. This is something that the slicer adds in to make sure the filament is flowing well when it starts the print. The first layer that goes onto the bed, and we can see the first layer here, what it looks like, is the most important layer. If the first layer doesn't go down correctly, the print is much more likely to fail, and it's much more likely to not look the way you want it to. We can also, this little thing down here lets us see, you can see the little simulated print head there. That's the extruder. We can see the order it's gonna print this stuff in. So it's gonna do this, this is called a skirt. This skirt first, and then it's going to do the 2 walls, 3 walls actually, and then it is going to print the rest of the bottom layer. And we could do that for every layer if we wanted to. Again, the 3D printer is going to do all this. That's not particularly interesting. I just wanted to point out that it gives you a really good understanding of what is being set up here to get printed. So let's go back to the prepare screen, and this is where we can change some of the settings. And I'm going to introduce, so we've got your settings visibility may not be the same as mine. You might see different settings. You might see not as many. So let me show you how to configure this in Cura. You can go to settings. You can go to configure settings visibility and select basic. Basic gives you sort of these basic settings over here, and that's what we'll be working with initially. And then we might get a little bit fancier once we get some more familiarity with this. So a couple of really, really important settings. Layer height. Layer height tells us how thick each layer is. You'll notice this says low quality up here, 0.28 millimeters, and 0.28 millimeters is really small. It is the largest layer height we can reasonably print with the type of 3D printer we've got. High quality, there are settings for this. High quality is more like 0.12 or 0.10 millimeters, but it's faster to print larger layers. So when we're doing stuff like this, we'll typically go with the largest layer height. We can set the number of walls, and so if you remember when we go to the preview, the walls are in red and green here, and that's sort of the outside. So if I set the, we can set either wall thickness or wall line count. So let's say I want to do 5 walls. You'll notice it'll go gray. It wants me to reslice it because I've changed the settings. And I actually have to close this because I can't get to the slice button. So when I hit slice here, it is going to reslice it, and this time is 28 minutes. It's going to take longer to print it now. And you'll notice I've got more walls. I've got 1 outer wall, and then I've got 4 inner walls. And so when I go to my infill layers, it's printing a little bit more plastic and it's spending more time doing walls. Now, if we had a need for a particular type of strength, we might want to increase the walls, but otherwise we can hit this little arrow here. This FX means it's normally calculated by set an absolute value. So what it really wants you to do is set the absolute wall thickness. If I set it to 1.6, it'll tell me that it's got 4 line counts. And the nozzle we're working with is a 0.4 millimeter nozzle. That's why a lot of these things are in increments of 0.4. Horizontal expansion. So some of these settings, there's a lot of settings here. I am not totally sure what all these do. Most of them you will never use. Top bottom thickness is one that tells you how many top and bottom layers there are. So we can set this by specifying a millimeter thickness, or we can just say I want 8 bottom layers and 8 top layers. So when I reslice this, it is going to add, it's going to take away from the time because I changed the walls. Let's put the walls back, and let's see if we can get a really slow cube here. So we're going to go back to 5 walls. We're going to have 8 top layers, 8 bottom layers, and you'll notice with just the top and bottom at 8, it was at 25 minutes. When we hit slice, it's at 31 minutes. Because the more moves you're doing, the more plastic you're extruding out of the 3D printer, the longer it's going to take. When I go to preview and look at this, I've got 1, 2, 3, 4, 5, 6, 7, 8 bottom layers, and I'm going to have 8 top layers. So this is going to be a very sturdy cube, which again is not really what we need. So if I were going to really print this cube, I would just use the defaults. Infill density is how much infill there is in there. If you crank this up, you'll get more infill. If you crank it down, you'll get less infill. A couple of other really important settings are printing temperature. Different materials. So the material we are going to work with in this class is called PLA. That stands for polylactic acid. It is a type of plastic that is based on corn. It has a very low melting point. 200 degrees Celsius is a pretty low melting point for a plastic. It's very safe to use. People often say that it is biodegradable. That's not exactly correct. It's digestible. But it's easier to send back into the environment than most plastics. And it's relatively cheap, so it's very, very good for 3D printing. So on these printers, we've actually got 2 different things that can heat up. We've got the printing temperature, which controls the temperature of the nozzle that extrudes out the plastic, and the build plate temperature. And so the build plate actually heats up, and the reason for that is it helps with adhesion. You can print PLA on an unheated build plate, but there's no reason to. It sticks better if the build plate is hot. 60 degrees is a standard setting. I know that 200 degrees works well for the filaments we'll be working with, but sometimes when you get a new filament, you have to change the temperature. I've had filaments print okay as low as 185 degrees Celsius, and I've had filaments need a temperature up into the 200s, like 220. These machines cannot go above 240 degrees Celsius. That is the maximum printable temperature, and we are unlikely to ever bring them close to that. Print speed is how fast it goes. We'll talk a little bit more about print speed, but 50 millimeters a second is a good speed. It takes about 20 minutes to print this cube at 50 millimeters a second. With default settings, that's totally fine. So the rest of these, we are not going to worry about right now. The layer height is really important. The wall and top and bottom thickness is something you might need to change if you need a little bit of additional strength. Same thing for infill density. But the really important parameters are printing temperature, build plate temperature, printing speed, and layer height. So those are the basics of slicing. And when you are done with this video, what I would like you to do is get into Cura, load up a cube, which I will provide for you, and prepare it to print with a temperature, and get something to write this down. Prepare it to print with a temperature of 195 degrees Celsius, a layer height of 0.3 millimeters, and let's say 2 top layers, 2 bottom layers, and 2 walls. You can leave print speed the same. You can leave build plate temperature. Everything else you can leave the same. So 195 degrees Celsius. I want 2 top layers, 2 bottom layers, 2 walls, and a 0.3 millimeter layer height. And when you are ready, get it in there, get it loaded, get it set. You will go ahead and slice it. And when you've got it sliced with those settings, let me know and I will come take a look, and this will be your first skills check. So after this video, we are going to talk about some common 3D printing errors, and we're going to take a look at some 3D printed objects, and we're going to do that in person. So thank you all for your attention, and like I said, when you're through this video and you have your cube plated and sliced, let me know and I will come take a look.